Hey everybody, this is Alex Merced, and again, if you've been liking these videos, make sure to like and subscribe and leave a comment and follow me on Twitter and LinkedIn. But what I want to talk about today is an introduction to SQL. So this is going to be more of a conceptual introduction, and then what we're going to do is we'll do a series of videos where we'll actually use SQL using SQLite, and then later on we'll actually apply it into the data lakehouse world using the Dremio platform. So this will be a fun series of videos. Now, cool. So first off, what is SQL? SQL, well, let's first discuss the term, is structured query language. Okay, so essentially it's a language for writing queries. Now, what's a query? A query is just a question. So you're essentially asking data questions, and it's a language to do so. Now, what makes SQL so special? I mean, part of it is that you can use it in so many different places. Because at the end of the day, there's a standard way of writing SQL. This is referred to as ANSI SQL. The SQL standard. And generally, that type of SQL can be used in most places. Okay, it just means it's a very sort of standardized way of writing SQL. Most places where you can write USQL, you can use a lot of that. But at the end of the day, SQL isn't, when there's a programming language or any kind of programming API or framework, there is the sort of the concept, the standard, and then there's the implementation. So for example, basically if I have a blueprint of a house, that's just a blueprint. It's not a house. But then when I build the house using the blueprint, that is an implementation of the blueprint. So it's the result. So the idea is that there are many SQL implementations used to talk to several different databases, data lakehouse platforms, data warehouses that exist. Okay, and what's beautiful about SQL is that it is declarative. Okay, so let's talk about what that declarative means, which means it's not imperative. So the idea here is when things are imperative, so usually if you just do things with like a raw programming language, so for example, if I were to write logic for asking questions on my data using Python, generally that logic is going to be very imperative. I'm going to actually have to describe each step. So I want to say, hey, load the data from this file. Okay, let's load it into this data structure. Okay, let me run these operations on that data structure. Okay, move this around here. Let's add these things together here in order to eventually get to my end result. Okay, so there's you have a bit more flexibility because you can describe every individual step, but you end up writing a lot more code and it can be a lot harder to think through. Okay, it's kind of like if I go to a restaurant and I talk to a waiter and say, hey, can you, and the waiter goes to me, can you place your order? And I go, yes, I would like for the chef to take 2 pieces of bread from the kitchen, put them on a plate, go get a knife, go get some peanut butter, bring the peanut butter over to the table, take the peanut butter, stick the knife in the peanut butter, spread it on the 2 pieces of bread, put the 2 pieces of bread together, put them on a plate, and give it to you to bring back to me. Notice how I described every step. That would be me ordering food imperatively. Okay? That's not generally how we order food. How do we generally order food? We do it declaratively, which means I say, I want a peanut butter and jelly sandwich. So I describe what I want. And then basically the implementation, the restaurant knows how to do it. So different restaurants that can give me a peanut butter sandwich or a peanut butter and jelly sandwich, each of them may do it slightly differently, but they all know what a peanut butter and jelly sandwich means. Okay, so in that same sense, SQL, when you write SQL, you describe what you're trying to ask, what you're trying to do. Now, how it is exactly done may differ from database to database, because each database has their own different implementation of SQL. But you don't have to worry about the difference in each implementation. You can just focus on sort of your desired result and expressing your desired result. Okay. So just to show you an example, okay, and then in the next video, we'll actually, create a database and query it. Okay. imagine this. Let me just make this extra large. So typically, the way the SQL language works is that any keyword is going to be in all caps. So typically, a query, me asking a question of data, usually starts with the word select. The idea is that I want something. I want to get some information from my data, and then what I do is I list the properties of that data that I want. Okay, so let's say here I want name, first name, last name, and then I say, hey, from which set of data do I want the data from? So I'll say from students, okay, and that's an example of a query. Okay, so notice I didn't tell it how to load where the student's data is. I didn't tell it how to load it. I didn't tell it how to process this query. I just said, hey, I want these two pieces of information from that data set. Okay, and then ended it with the semicolon. So you see that the words that represent sort of built-in words in SQL are typically written in uppercase, and then generally things that represent sort of unique custom things, like they're not built into SQL, like the names, like how that student data is structured and the different properties it has, that is not built into SQL, it's built into the data set. And then the name of the data set, well, that's also not built into SQL. So those things are going to be lowercase. Okay. So as you can see the syntax, and then again, once I express what I wanted to say, so I expressed my query or my question, I just end it with semicolons. So generally, even if you didn't know SQL, you could probably kind of reason what this means. I want the first name and last name of students. Okay? And that's the beauty of SQL. Like, it's very expressive and declarative in the sense that I can express all sorts of types of questions in a way that basically I'm focusing on sort of the desired result, not on the how to achieve the desired result. And that's why it's so popular, okay? Because it's generally declarative abstractions. And the word abstraction means to sort of hide the complexities with something simpler. So essentially, an SQL is an abstraction over whatever database operations that particular database actually does under the hood, tend to be very popular. Okay, so for example, when it comes to developing websites, React is an abstraction over a lot of HTML, CSS, and JavaScript. So that is the concept of SQL, which again is very portable among many different databases, such as like Postgres, MySQL, and SQLite 3, which is SQLite 3 is what we'll be using for kind of introducing and working with SQL to begin with. Data lakehouse platforms like Dremio, which we'll be using later on, and also different data warehouse platforms and even other applications from there. Okay, so SQL just gets applied anywhere where oftentimes you need to ask questions of data. Now again, keep in mind, not all implementations are identical. So the SQL syntax, the actual keywords and things you can do can change from database to database, from platform to platform, but the general idea of SQL tends to remain consistent, making it a very portable tool, a portable knowledge or skill that you can use to take advantage of lots of different tools, making it, again, super powerful, super important to learn. So again, my name is Alex Merced. Hopefully you guys enjoyed the video. Again, if you did, like, subscribe, leave a comment. I'll see you on the next one where we'll actually, start getting hands-on.